Hello everyone, I'm Karthik from ITA section. Today on concept video, my topic is about quality of service in computer networks. Let us discuss what is a quality of service and what are its services. In further slides briefly, I am going to discuss this quality of service in further slides. Let us dive into our topic. What is QoS in networking? Quality of service, which is also called as QoS, is the use of mechanism or technologies that work on a network control traffic and ensure the performance of a critical application with limited network capacity. It enables the organization to adjust their overall network traffic by prioritizing specific high performance applications. QoS typing QoS is typically applied to networks that carry traffic for resource intensive systems. Common services for which it is required include Internet Protocol television, that is IPTV, online gaming, streaming media, video conferencing, and video on demand, that is VOD, and voice over IP, that is VoIP. So this is QoS, which is the mechanism or technologies that work on the network to control the traffic and ensure the performance of the critical applications which with a limited network capacity. So let us know some more information about quality of service in the further slides. So a overview of quality of service. Let us see what it's. So quality of service mainly focuses on measure of error network and throughput mechanism, applications SLA of bandwidth requirements, traffic protocols, and users packets, telecommunications rates, telephony, latency, and performance standard, availability control, computer control, jitter, etc. These are the main things which quality of service focuses on to ensure a better experience to the user. How does QoS work? QoS network technologies work by marking packets to identify service types, then configuring routers to create separate virtual queues for each applications based on their priority. As a result, bandwidth is reserved for critical applications or websites that have been assigned priority access. Uh, Quality of service technologies provide capacity and handling allocations to specific flows in a network traffic. This enables the network administrator to assign the order in which the packets are handled and provide the appropriate amount of bandwidth to each application or traffic flow. So, types of network traffic. Understanding how QoS network software works is reliant on defining the various types of traffic that it measures. These are bandwidth, the speed of the link. QoS tell a router how to use bandwidth. For example, assigning a certain amount of bandwidth to different queues for different traffic types. Delay, the time it takes for packet to go from its source to its destinations. This can be often be affected by the queuing delay which occurs during the time of congestion, and a packet waits in a queue before being transmitted. QoS enables organizations to avoid this by creating priority queue for certain types of traffic. Loss, the amount of data lost as a result of a packet loss, which typically occurs due to the network congestion, QoS enables organization to decide which packets to drop in this event. Jitter, the irregular speed of packets on a network as a result of a congestion which can result in packets arriving late and out of sequence. This can cause a distortion of or gaps in audio and video being delivered. So the various types of a traffic that QoS measures, that is bandwidth, delay, loss and jitter, which we have discussed in the previous slide. What are specifically we have discussed about each and every single bandwidth, delay, loss and jitter. So getting started with QoS. Implementing quality of service begins with an enterprise identifying the types of traffic that are important to them to use high volumes of bandwidth and or more sensitive to latency packet loss. This helps the organization understand the need and importance of each traffic type on its network and design an overall approach. For example, some organizations may only need to configure bandwidth limits for specific services, whereas others may need to fully configure interface and a security policy bandwidth limits for their services, as well as the prioritize queuing critical services related to traffic rate. The organization can then deploy policies that classify traffic and ensure the availability of a consistency of its most important applications. Traffic can be classified by port or internet protocol, or through a more sophisticated approach such as by an application or a user. Bandwidth management and queuing tools are then assigned roles to handle the traffic flow specifically based on the classifications they received when they entered the network. This allows for packets within the traffic flows to be stored until the network is ready to process them. Priority queuing can also be used to ensure the necessary availability and minimal latency of a network performance for important applications and traffic. So these are some images on quality of service. Here we are using a source and the network and to reach the destinations. So why is a QoS is important? So let us discuss. Traditionally business networks operated as separate entities. Phone calls and teleconferences were handled by one network, while laptops, desktop servers and the other devices connected to another. They rarely crossed the path unless a computer used a telephone line to access the internet. When network only carried data, speed was not overall critical, but now interactive applications carrying the audio and the video content need to be delivered at high speed without packet loss or variations in delivery speed. QoS is particularly important to guarantee the high performance of critical applications that require high bandwidth for real-time traffic. For example, it helps a business to prioritize the performance of inelastic applications that often have minimum bandwidth requirement, maximum latency limits, and highly sensitive to jitter and latency, such as VoIP and video conferencing. What techniques and best practices are involved in a QoS? Techniques, there are several techniques that business can be guarantee the high performance of their most critical applications. This include prioritization of delay sensitive VoIP traffic via routers and switches. Many enterprise networks can become over congested, which sees routers and switches start dropping packets as they come in and out faster than they can be processed. Resource reservation. The Resource Reservation Protocol (RSVP) is a transport layer protocol that reserves resource across a network that can be used by deliver specific levels of a QoS for applications data streams. Queuing is the process of creating policies that provide preferential treatment to certain data streams over others. Traffic marking. When applications that require priority over other bandwidth on a network have been identified, the traffic needs to be marked. This is possible through process like a class of service COS. Quality of service, which mainly focuses on stability, capacity, architecture, performance tuning, performance testing, availability and disaster require recovery, usability review, security. Advantages of a QoS: unlimited application prioritization. QoS uh, Unlimited application prioritization, better resource management, enhanced user performance, point-to-point traffic management. The These are the advantages of quality of service, which in which unlimited application prioritization QoS guarantees the business's most mission critical applications, and QoS enables better resource management to the administrators to better manage the organization's internet resources and enhanced user experience. The end goal of the QoS is to guarantee the high performance to the critical applications and point-to-point traffic management, managing a network of a vital vital traffic if they are delivered. These are the advantages of the quality of services. Thank you. This is about the quality of service.